Hannah. Have you ever wondered what keeps you in the seat on a huge loop-de-loop roller coaster? Surprisingly, it's not the seatbelt that keeps you in your seat, but in fact the seat itself. It works because of something called Centripetal Force, and it does way more to make an awesome roller coaster. Centripetal Force keeps a satellite in orbit and you in your bicycle seat during a turn. But how exactly does it work? You have probably heard the famous story about Sir Isaac Newton and the discovery of gravity when an apple fell on his head while sitting beneath an apple tree. Whether or not this story is true, Newton was a careful observer of the world around him. His plan was to use mathematics and science to describe a natural phenomenon which at the time were not understood. Newton made many discoveries: the law of gravity, colors, prisms, advanced mathematics, and motion. Newton's 3 laws of motion are still used today, and these principles can be found in almost any modern moving technology. Newton's first law of motion is often stated as, objects at rest stay in rest, and objects in motion stay in motion. This simply means that once you are still, it is hard to get moving, and once you're moving, it's hard to stay still. Newton discovered that in order to get an object to move, the object must experience a force that makes it move in a certain direction. Once the object experiences this force, it is set in motion and will continue this motion until it experiences an opposite force that causes the motion to stop. You have felt this phenomenon when riding in the car. When the car starts moving, you rock backward because your body wants to stay in a stationary position. Like how I'm going really fast, but after you start moving, the car suddenly stops because you rock forward because your body wants to keep going forward. And now you're gonna go around a loop. See? When you do that, you want to stay in a stationary position, but you can't because it's going in a loop. You want to keep going straight, but your body leans over to the right. Well then, now that we stopped the car, I can finally explain what happened. If your body wants to move away from the center, why are you moving in a circular path? This is called centripetal force, or a force that makes an object move or accelerate towards the center of the circle. Without centripetal force, the object would move in a line. In the car, for example, the way the car, gravity, and the friction of the road keep you in your seat moving in a circle. Do not confuse centripetal force with centrifugal force. Centrifugal force is not actually a force, aka it's not real, but a tendency for an object to leave the circular path and fly off in a straight line. Now back to the loop-de-loop on the roller coaster. The track is moving in a circle, and we move along with it. But what is keeping us in our seat? Gravity is a force that pushes us down towards the ground, which may help us stay in our seat at the bottom of the loop. But it probably doesn't help us stay in our seat at the top of the loop. The force from our seatbelt may help us stay in our seat, but just mostly at the top of the loop. Centripetal force is a force that must be constantly pulling us towards the center of the loop, and not just at the bottom of the loop or the top of the loop. Now we're going to do a physics science project in order to investigate the movement of an object during circular motion in order to determine what the centripetal force is that keeps the object moving in a circular motion. For this experiment, you will need a plastic cup, some glass beads, like these, and 2 different colors of Jell-O in order to fill up the cups. You're also going to need some string, a flashlight, duct tape, and scissors. To begin this experiment, make a package of Jell-O by following the instructions on the back of the box, except use more cold water than what it recommends. Making Jell-O using warm water will make it less thick and more viscous. This will make it easier for the bead to move when you are testing it later. Place the Jell-O in 3 plastic cups, filling each cup halfway. These will be your test chambers for centripetal force. Place the cups in a refrigerator and refrigerate them for at least 4 hours. I did this last night so that way I could fill in the second layer. After the Jell-O is done and firm, make the second batch by preparing it the way you did in step 1. Place the glass bead on top of the Jell-O in the center of the cup, like this one right here. Gently press the bead into the jello until it's secure and will not slide around. Now slowly and carefully pour the second batch of jello into the cups, covering the first layer and the glass bead until the cups are almost full. You have to be careful not to damage the first layer, like how I did with this one. Don't worry if the first 2 layers of gel mix together a little while and meet. However, make sure to check that the bead stays roughly in the middle between the 2 layers, like this one. It's not that clear, but you could still see it. While your jello solidifies, prepare your centripetal force generator. You will be testing your chambers inside of the generator. Take an empty plastic cup and use the scissors to make a small hole about 2.5 centimeters from the top of the rim of the cup. Then make a second hole on the opposite side of the cup. Place a small piece of duct tape on the edge of the cup. This will help prevent the string from detaching. Attach the string for the hole and tie the bowline knot to just secure the string. Your generator should look something like this. This will be your centripetal force generator. Make sure the string is strongly attached to the cup. Now that your jello is firm, take one of your cups and place it in the centripetal force generator by stacking the plastic cup with the jello into the plastic cup with the string. Make sure you use the cup that has the bead in the center, and you might want to make more than one in case the bead does not end up centered like these 2, because those 2 are for eating, so. Ta-da! Now take this stacked cup outside into an open area. In this case, we're gonna go out to my backyard. Let's go! Now hold the string and quickly twirl the cup around your head for 20 revolutions. You must spin the cup hard and fast to get enough centripetal force for the bead to move down to the bottom of the cup. You ready? Look, there it is. As you can see, the bead moved from the middle of the cup to the bottom. When an object moves or accelerates in a circle, the object wants to move out, away from the circle's center. Without the push of centripetal force, the object would move in a line, flying out and away from the circle. For example, if I had let go of the cups while I was spinning them, it would have flown away in a straight line. The bead in the spinning cups also wanted to move away from the center of the circle. In this science experiment, centripetal force is supplied by the tension of the string. The force keeps the cups moving in a circular path. This is a pull force, similar to how satellites are kept in orbit due to the pull of Earth's gravity. A push centripetal force acted upon the bead. This force supplied by the bottom of the cup kept the bead going in a circular path and not flying away in a straight line. A push centripetal force also keeps you in your seat on a loop-de-loop ride on a roller coaster and when you're making a turn on your bicycle. And here's the best part. You get to eat the Jell-O. Centripetal force. Rock backward because your body wants to stay in a stationary position like this. Oh my god, that's really fast. Alright, wait.
Did she rock it all?
No, she didn't. It was rather depressing.
Alright, let's try that again.
Okay.
Baby!
She made a real cat noise for you.
I know! You want to keep going straight, but your body leans over to the right.
Thanks, Dad.